Okay, this is Intro to Coordinate Trigonometry, and coordinate means we are working on the coordinate plane. So today what we're going to look at are triangles in the coordinate plane and all four quadrants. So it says here to pick any point in the plane and form a triangle with a perpendicular line from the point to the x-axis and then a diagonal line from the point to the origin. So we're going to go ahead and place a point in the first quadrant. So I'm going to go ahead and do that. And then I'm going to draw a perpendicular line down to the x-axis. And I'm going to draw then from that point, I'm then going to extend it to the origin. And so I have a right triangle constructed with the x-axis. So this ordered pair that I just picked, we all picked different ordered pairs. It has a value of x, comma, y. It was so far over to the right and so far up from the axis, which means this triangle that we have drawn here has a height of y, a length of x, and this line here from the origin here, this is going to be r. This is going to stand for radius of a unit circle, and that'll make more sense when we go through notes in the next set. This angle here, this angle is going to be theta. It's an unknown angle measurement. So we want to talk about trigonometry in the first quadrant. What would the trigonometry for this triangle look like? And so the sine of theta, if I wanted to find out what theta was using sine, the sine of theta, as you know, using SOHCAHTOA, is going to be the opposite over the hypotenuse. So from theta, my opposite is y, my hypotenuse is r. The cosine of theta is adjacent. From theta, x is adjacent, and r is my hypotenuse. And the tangent of theta is opposite over adjacent, and so it's going to be y over x. Now in the first quadrant, x and y, they're both positive. Let's look at what happens in the second quadrant. So we're going to do the same thing. We're going to place an ordered point anywhere in the second quadrant. We're going to draw a perpendicular line down to the x-axis, and we're going to draw in the hypotenuse of this right triangle that we just constructed. And so again, this ordered pair now, we went on the negative direction of the x-axis. This is negative x, but y is still going up. That's a positive direction of y. And so now let's label this triangle. This side y is going to be positive, x is going to be negative x, r, and now again still this unknown theta. So the sine of theta, from theta, y is opposite, r is the hypotenuse, and x is the adjacent piece. So sine is going to be y, the length of y divided by the length of r. The cosine of angle theta is equal to negative x over positive r. And the tangent of theta is positive y over negative x for TOA. All right, at this time I want you to pause the video and I want you to try the third quadrant and the fourth quadrant, noticing that both x and y are going to be negative on the third quadrant. When you are done trying 3 and 4, hit play. All right, so let's take a look and see how you did on quadrant 3. So quadrant 3 here, I went ahead and labeled my opposite, adjacent, and hypotenuse with the green letters here. So here's my theta. Negative y is my opposite. X is still my adjacent. X and y are both negative. My ordered pair is negative x, negative y. So sine of theta was negative y over r. Cosine of theta is negative x over r. And tangent of theta is negative y over negative x. On the fourth quadrant, we're going down here, we're picking our point, drawing a perpendicular line. We always go to the x-axis with the perpendicular line. Here's my length of r, my length of x. Sine of theta is going to be negative y over r, cosine is x over r, and tangent is negative y over x. So notice that on quadrants 1, 2, 3, and 4, sine is always y over r. Cosine is always x over r, and tangent is always y over x. Now, some of those are negatives, and that depends on what quadrant you're in, but you should see a pattern there. We're going to continue to use that information as we use trigonometry. So be sure to send me a Schoology message if you have any questions over why we labeled those trig functions the way we did. Let's look at the last example here, or an example. Just a friendly reminder how we would, we're using straightforward trigonometry for you to complete the back side of this notes paper. And here's an example. So here it says you need to find theta, which you're going to be using inverse trig to find an angle, and then you're going to find the length of r. Round your answers to 2 decimal places. Okay, so because this ordered pair is telling us it's 5, 7, we know that the length of x is 5 because this is x comma y, and the length of y is 7. So 5, 7 there for my lengths. So if I want to find theta, I'm going to have to use 7 and 5. So from here, 7 is the opposite, 5 is the adjacent. So that means that we're going to use tangent to find the length or the value, the angle measure of theta. So tangent of theta is 7 over 5. And to get theta by itself, we're going to have to do tangent inverse. So tangent inverse theta is going to equal tangent inverse of 7 over 5. Make sure your calculator is in degree mode, and you're going to type that in, and you're going to get 54.46 degrees. Now, to find r, now that we know that this is 54.46, we're going to find the length of r. Now, it's really important that you round to 2 decimal places because we're trying to find the closest value for r that we can, and we don't want to round it off too soon. So you could use sine or cosine to find the length of, or I'm sorry, we cannot use, we could, yes, sine and cosine. I'm going to go ahead and show you what sine, or excuse me, cosine would look like. I want to use this 5. So from theta, 5 is the adjacent and r is the hypotenuse. So if I say cosine of 54.46 degrees, that is going to equal my adjacent over my hypotenuse, which is 5 over r. Remember, when the variable's in the bottom, we are going to swap them and divide. So the length of r is going to equal 5 divided by the cosine of 54.46. We're going to type that into the calculator, and r is going to have a length of 8.60. So this is what this process here, for example number 1, is what you're going to practice on the back of this worksheet on questions 1 through 6. And then you're going to practice using your calculator on 7 through 12. When you're done doing that, you can then check your answers, but please do make sure that you attempt all of those problems.